To assess the quality of the model, we perform the Young box test on the residual to track for optocorrelations. This test evaluates whether the residuals are independently distributed. If you see in the screen, that is the test we are conducting in this program. There are two hypotheses in this test. The first one is a null hypothesis. It states the residuals are independently distributed, no optocorrelations. The other one is alternative hypothesis. It says that the residuals show optocorrelation. The p-value of this test is going to be 0.9962. It indicates that we failed to reject the null hypothesis, meaning that there's no significant optocorrelation in the residuals. Again, because the value is much greater than the benchmark 0.05. This suggests that the model adequately captures the underlying structure of the time series. Now we move on to look at another test. We analyze the residuals of a fitted model and using the functions called track residuals. This function provides several important diagnostic plots, each serving a specific purpose in evaluating the model performances. The first plot you can see is showing the residuals, the difference between the observed and the predicted value over time. The residuals should fluctuate randomly around zero, resembling the white noise. Ideally, there should be no visible pattern or trends. If the residual appear random, the model have adequately captured the underlying patterns in the data. As you've seen on the diagram, if there are visible patterns, trend, or non-zero mean, it might indicate that the model still needs to capture the data structure fully. The next diagram or next plot we are talking about is the optocorrelation functions plot, showing the correlation between the residual at different lags. Ideally, the residual should exhibit no significant optocorrelations, meaning that the ACF should be close to zero of all lags. If there's no significant spike in the ACF plot, it suggests that the model has captured all optocorrelations present in the data. If significant spikes are present, it indicates remaining optocorrelation in the residuals, meaning the model may need refinement. Finally, we're looking at the histogram of residuals. This histogram shows distributions of the residuals. The residuals show ideally follow a normal distributions with a mean of zero. A bell-shaped histogram indicates that the residuals are approximately normally distributed. If the histogram shows skewness or heavily tailed, it suggests that the residuals do not follow a normal distributions and the model may need improvement. Finally, if we want to talk about the syntax, there's something I want to mention about it. We use let equal to log length simulated a mirror. Basically, this line is very important in the Young box test because we're going to select a reasonable number of lets for testing optocorrelation. The logarithms ensure that the number of lets grows more slowly as data sets increases, balancing the need to detect optocorrelation without overfitting. This method is essential and efficient because it avoids too many lags, which could reduce the test's power while still capture potential patterns in the residual.